everybody. Thanks again for joining the Nashville Parthenon Symposium today. We're so glad you could be here. My name is Katie Petroli, and I work at the Nashville Parthenon. I'm the Director of Education. And today's symposium is connected to our newest temporary exhibit called the Antikythera Mechanism. The exhibit and its symposia are funded in part by a grant from Humanities Tennessee, which is an independent affiliate of the National Endowment for Humanities. This program today is also sponsored by the Centennial Park Conservancy, who funds all the Parthenon programming and exhibitions, as well as Metro Parks Nashville, who owns and operates the Nashville Parthenon Museum, which is coming up on its 125th year very soon. This is the second of our 3 summer symposia that are connected to the Antikythera mechanism. If you can, I recommend coming to the Nashville Parthenon to see the exhibit or checking out our website, nashvilleparthenon.com, that will have a digital exhibit up very soon. Today's virtual talk will be all about the conservation and preservation of bronze artifacts. Specifically, that includes the Antikythera mechanism, thanks to our speaker, Dr. Georgianna Moraitou. Our next symposium will be on August 18th with the expert archaeologist, Dr. Anne DeRay, and she will be speaking all about underwater archaeology. So we encourage you to register for our next one as well. And if you missed our first one, it was back in June, and there is a video available online on youtube.com/Nashville Parthenon. I'd be happy to send that to you if you need it. Our symposia are free and open to the public, so I welcome you to join us for any symposia now or in the future. We hope to increase your knowledge of archaeology in the ancient world today, following the mission of our Nashville Parthenon. So that means if you have any questions, we would love to hear your questions, and you can add them to the chat function at the bottom of your Zoom platform here. You can also use the Q&A function. And at the end of our talk today, I will be taking your questions and asking them to our esteemed speakers so that we can have a dialogue back and forth and make sure all your questions are answered about archaeology and the ancient world. So I will also be in contact to share a recording of this talk. That email from me will include a link to a survey. And if you'd like to help your survey karma, we'd love to hear your responses about this program. It's incredibly important for us so that we can continue to improve our programming and then also analyze the results for grant reporting purposes. So that would be really helpful. And thank you in advance for taking a very pain-free short survey. With that said, you can feel free to message me anytime. I'm on here as Nashville Parthenon. During today's presentation, if you're having technical issues, I'll be working behind the scenes to problem solve during the talk. So feel free to message Nashville Parthenon directly at any point. And now it is my pleasure to introduce our speaker today. We are delighted to present Dr. Georgianna Moraitou. She is the head of Conservation, Physical and Chemical Research and Archaeometry Department at the National Archaeological Museum in Athens, Greece, which is part of the Hellenic Ministry of Culture. She received her PhD from the National Technical University of Athens. She's a research member of international and national EU-funded research projects. She has taught conservation. She's a visiting lecturer and has published 64 papers in scientific journals and international conference proceedings. So in addition to this very impressive list, she also recently published a monograph titled Othon e Rousopoulos and the Early History of Scientific Archaeological Conservation in Greece, published by the Archaeological Research Fund. So if you can't tell, we are delighted to be joined by Dr. Moraitou. In just a second, I will be letting her share her screen. So please join me in welcoming Dr. Moraitou.
Thank you, Katie. Good morning, Nashville. It's 6 o'clock in the afternoon in Greece, and I am Georgianna Moraitou, and I'm going to introduce you to the conservation of bronze antiquities. So, bronze antiquities at the National Archaeological Museum in Athens, and special focus will be given on case studies from the Antikythera shipwreck. The National Archaeological Museum opened its doors in 1885. It is one of the oldest museums in Europe, in the world, I should say. It possesses the most important collection of large-scale bronze statues of ancient Greek art. In this slide, we see Poseidon from Livadostra, the youth from Antikythera, the god from Artemision, the horse and jockey from Artemision, and the youth from Saarbrücken. What these statues have in common is that they were found in the sea. The bottom of the sea has preserved these precious bronze statues, which would otherwise have been destroyed and recycled in the course of time. Because of the expertise of the National Archaeological Museum in the mounting of these bronze statues, other cultural agencies and museums in Greece allocate their finds to us in order to be mounted. These are some statues under the custody of the FR8 of Underwater Antiquities that have been allocated to the museum in order to be mounted. But what is bronze? Bronze is an alloy of copper and tin in a ratio of approximately 85% copper and 10% tin, together with other minor constituents. From the time of discovery, archaeological finds are subject to a series of conservation interventions which will preserve them and make them presentable to scholars and the public. The conservation approach includes scientific examination, cleaning, stabilization, consolidation, assembly, gap filling, what is called restoration, protection, mounting for display, and documentation. Let's see each one of these interventions. Scientific examination is the diagnostic protocol applied to artifacts in order to reveal their internal structure and the materials they are made of. What we apply at the National Archaeological Museum is radiography, X-rays for imaging, and X-ray fluorescent spectroscopy for elemental analysis. This preliminary stage of conservation may be paralleled with the medical diagnostic stage. Cleaning. Objects retrieved from the sea are corroded and encrusted with marine organisms. They are also impregnated with soluble salts, mainly sodium chloride, which is detrimental to the metals. First, the objects must be desalinated, then the concretions must be removed, and this is usually done mechanically. The surface of the bronze, what is called epidermis, this is a Greek word, is converted to corrosion products consisting in copper oxides, copper carbonates, and other minerals, mainly copper minerals. It is much praised aesthetically and must be preserved. This is called the patina of the bronze, and it is highly praised aesthetically and must be preserved. Sometimes the bronze objects are completely corroded and converted to corrosion products, and there is no metallic core inside. Stabilization is the application of a corrosion inhibitor which will halt any further corrosion. Bronzes from underwater sites are susceptible to the so-called bronze disease, a cyclic corrosion mechanism involving moisture and chloride ions, which, if untreated, may destroy the object completely. If the object is friable, it has to be consolidated. For this, we use synthetic resins. Protection consists in the application of a surface varnish of synthetic resin on the object in order to isolate it from the moisture of the atmosphere and from handling. If the object is found broken in pieces, it is assembled using a suitable adhesive. Gaps may be filled with a suitably colored resin in order to give structural stability and visual integrity to the object. Gap filling, as we see here, gap filling, is not always necessary. We follow a rule which recommends minimum intervention. Finally, the object, if not stored, is mounted for exhibition. At the National Archaeological Museum, conservators design and fabricate tailor-made mounts for each object. The mounts are either made in perspex or in stainless steel. We're now going to see how large-scale bronzes are mounted. Mounting takes advantage of the fact that large statues are hollow inside, bronze statues. This is because they had a clay core in order to minimize the quantity of metal used. First, the exact place of the holding inside periphery is estimated in the center of the statue. Then two horizontal plates are made out of plywood. Then the whole system is designed with a computer, and the actual parts are ordered from a stainless steel contractor. The mount consists in a vertical axis and the two transversal plates. Some devices are foreseen to permit the regulation of the posture. You see these devices of the posture of the statue. Another rule we follow in conservation is that all interventions must be reversible. So the mounts are not invasive and can be removed at any time. Remember this when we speak about the interventions made in the beginning of the 20th century on the youth from Antikythera. Last but not least, documentation in writing and photography is made before, during, and after conservation. We're now going to see some case studies from the Antikythera wreck. The Antikythera shipwreck was discovered by sponge divers in the year 1900 off the coast of the island of Antikythera, which lies between the Peloponnese and Crete. The unexpected find was reported to the Archaeological Service, and the first lifting of the cargo took place in the years 1900-1901. The sinking of the vessel is dated in the 1st century BC. The youth from Antikythera was recovered in 5 large pieces and some smaller from a depth of 63.70 meters. The finds were transported to the National Archaeological Museum for conservation and display. In June 1901, the statue was allocated to the chemist Othon Roussopoulos for conservation. Othon was the son of Athanasios, a university professor of archaeology in Athens. He had previously conserved the marble polychrome sculptures and bronze votive offerings from the excavations on the Acropolis of Athens. The first thing he did is to desalinate the pieces of the statue in fresh water. Next comes the cleaning, the removal of the accretions, the biological accretions, and the corrosion products. At the time, the standard method for the cleaning of bronzes was the use of acid. Rousopoulos innovated by introducing the electrochemical cleaning. In this method, the object to be cleaned is folded in strips of zinc, which is a more electronegative metal. The whole is immersed in an electrolyte. What happens then is the creation of a battery. Electrons are directed from the anode to the cathode in an electric current. The anode, that is the zinc, is consumed, while on the cathode, that is the object, hydrogen is generated and the corrosion products are either pushed away or reduced to a metallic state. Unfortunately, although the method was effective in the treatment of bronze disease, and it did not attack the metal as the acids did, it destroyed the natural green patina and left the bronze in a blackish state. Archaeologists did not like the loss of the patina and criticized the method. Nevertheless, this method continued, especially in the United States, in American museums, but in a similar method using an external current that was, we see here a slide where the external current goes to the electrolyte, where the anode is platinum and the object is made the cathode. But who assembled and mounted? But let's go back to the youth, which at the time was called Hermes or Paris. Who performed the restoration of the statue? Who assembled and mounted it? Well, the Greek government had looked for a competent restorer around Europe. Othon Rousopoulos was a chemist. He did conservation. He did not do restoration. So the Greek government looked for a competent restorer around Europe, Cairo, and Constantinople, where the oldest museums were established. Finally, the restoration of the youth from Antikythera and the mounting was allocated to Alfred André, a French restorer. André came to Athens with his two assistants in August 1902. He had already fabricated the internal skeleton. What we see here is that he used a mechanical method for the assembly of the pieces. He used metal plates across joints, across breakages, which he secured with screws and bolts. This is a very invasive method which perforates the walls of the statue. Can you see here the holes? It's full of holes, the statue. We also see the metal ring secured on a vertical axis. The axis ends in two further vertical axes, one for each leg. And the axis was secured by André with a cement on the bottom of the feet. The restoration lasted 2 months, and the final result was so perfect that the joins were not discernible. This is another not to do for conservators. because the third rule in conservation says 2 feet, 2 inches. That is, the intervention can be invisible at 2 feet distance, but must be discernible at a distance of 2 inches. The Greek side was so pleased that André, not only was he paid with the sum of 6,000 drachmas, but he was even awarded with a gold medal. It is worth noting here that Rousopoulos was paid with 3,000 drachmas. I have to say that finally, André did not do a perfect job, because in 1957, the youth from Antikythera was deassembled and reassembled in order to correct some details in his posture. This is the gap filling. And this is the youth as it was restored and mounted. And this is a view of the gallery where it is exhibited today. Another bronze statue retrieved from Antikythera was the statue of a philosopher. He was lifted in 7 pieces: the head, the right arm, the left hand, the 2 sandaled feet, and 2 fragments of his garment. This is a 2-dimension reconstruction of the statue by Svoronos in 1903. And this is the head before conservation and after conservation by Othon Rousopoulos. The head today, this is the exhibition showcases. Well, the head is exhibited on its own in one showcase, and the rest are exhibited in another showcase. The hands are off now for conservation. We now come to the most famous masterpiece of the Antikythera wreck, the mechanism. This is the oldest known astronomical and calendric calculator and has been designated as the world's first computer. It seems that the device was lifted from the seabed in one piece, looking similar to an amorphous rock. It may be that because it was left unnoticed for some months, it broke in 4 pieces. This is a photograph of the mechanism in the 1903 publication. These pieces are named A, B, C, D. A, B, C, D. In a newspaper, the 23rd of May, 1902, Svoronos, the archaeologist, recommends that the device is examined by an astronomer before any attempt of cleaning, which might destroy it. In another newspaper of the time, the 4th of June, 1902, we read, "In a few days, the cleaning of the device will take place." Nevertheless, in his 13th report to the minister, dated the 1st of December, 1903, Rousopoulos says, "To my humble opinion, the astronomical device cannot undergo chemical cleaning, but maybe it is not pointless to ask the opinion of other chemists, especially that of the director of the chemical laboratory of the Berlin Museum, Professor Rathgen." Finally, in his 1905 and 1911 publications, Rousopoulos states that the astrolabe, as it was called at the time, the astronomical device, which did not have a metallic core, was cleaned with potassium cyanide. Othon Rousopoulos described it as a delicate task, and I quote, Apart from being a difficult and perilous undertaking, its conservation was an arduous and painstaking process. He carefully separated layers of plate that had become stuck together. The most significant consequence of the separation of these fragments is that the fragments were made accessible and new data was exposed. In the course of time, more fragments were discovered in the storeroom, making the total number of fragments attributed to the mechanism to be 82. We see here fragment A, B, C, D, E, F. On fragment E, there are remains of wood because the whole device was fabricated in a wooden case. And fragment G is very important because there is inscription which has been read. We are going to see how the experts read the inscription. Although X-rays were discovered in 1895, they were not used on the mechanism until the 1950s. And these are X-rays from the 1950s that were made at the National Research Center, Demokritos. It is said that only 1/3 of the mechanism is preserved. And since 1902, numerous scientists and teams of interdisciplinary scholars have studied it and produced different models. This is a model of the mechanism, a modern reconstruction. The most important study of the mechanism was implemented in 2005 by an international research team with a weighing 3-ton CT scanner, which was transported from England to the museum, to the National Archaeological Museum. This study gave an insight to the inscription, the shape, and the function of the mechanism. You know what a CT is and how it works in layers, and the layers are revealed, and the inscription and the gears, etc., are revealed. And this is how the mechanism is exhibited at the moment at the National Archaeological Museum. And this was a visit to the back scenes and history of the National Archaeological Museum, and we have now reached the end of the presentation. Before I close, I would like to thank my colleagues, Dr. Anna Vasiliki Karapanagiotou, the director of the National Archaeological Museum, my colleagues Gerasimos Makris, Georgia Karamariou, Pantelis Feleris, conservators at the Metal Conservation Laboratory, and George Kouros, our chemist. Finally, I present you with a concise bibliography, and I thank you very much for listening.
Well, I don't know about you all, but I feel so special. We just got this behind the scenes look at one of the most, significant technological artifacts and all of its finds. My mind is blown away. So thank you so much, Dr. Moraitou. At this point, we would love to hear your questions, hear your thoughts, comments. You can use the chat function. You can use the Q&A function. We have a couple questions already. So, Dr. Moraitou, I believe you can stop sharing your screen. That way they might be able to see you better.
Good.
Let's see. Our first question comes from Anna Graham, and it's a two-parter. If a sculpture has needed gap filling, what kind of material is used for that? And is mounting these sculptures more difficult?
We used synthetic resins, which have structural stability today, which are epoxy resins, special epoxy putties and the resins. Mm-hmm. About the mounting of the sculptures, it's a highly expertise job. That this know-how is only at the National Archaeological Museum. This is why all the agencies, the underwater Aphoret of Antiquities, they bring all these statues to us to mount. It's a know-how that begins from the end of the 19th century. And it is it evaluates, and it has become non-invasive.
Thank you. Our next question comes from Liana Chalk. She asks, what were bronze statues mounted on originally in antiquity? And were they always freestanding?
They had an internal clay core, and inside the clay core was metal, an iron armature skeleton. But once the statue was made in the lost wax technique, once it was I don't remember the word.
Lost wax.
Cast. Once it was cast, the artist removed the clay core, and they mounted the statue with lead tenons and joints on the feet, on stone bases. So they were empty inside. Well, the Riace bronzes, they still have their core inside, the clay core.
I didn't know that.
Yes.
Wow.
You know the Riace bronzes, they are Greek, of course, but they are exhibited in Italy. They were found in Italy.
That's amazing. Thank you. Yeah. I mean, I know that we have found statue bases, but it's always good to remember that statues that are bronze were sometimes displayed differently than statues that were marble or stone. So
you can still see the feet now on the stone bases.
But cuttings and carvings where the feet would fit. Yeah. Yeah. Well, great question, Liana. Our next one comes from Mark Corral. Apologies if I'm not pronouncing your name correctly. Is there a lot of consultations between preservators of Viking artifacts and Chinese artifacts, etc.? And are there major differences in approaches?
In the conservation, in the approach, the conservation approach? No, I think worldwide we have the same corrosion inhibitors, the same conservation materials we're using. And also I read the question, if bronzes are found elsewhere than in the sea. Yes? Yes, they are found, but it's very, very rare. For example, the charioteer in Delphi was found on a land dig, and also some other statues. But it's very, very rare because usually they were destroyed and they were recycled.
Melted down, reused.
Copper. Yes, copper is a luxury metal.
Here is our next question. Are the inscriptions on the device visible to the naked eye now? And to what extent do the CT scans reveal additional text?
Yes, some of them are visible, and the CT scan revealed many more clues. And the fragment I show you, fragment F, is the manual of the device, of the mechanism. There was a manual how to use it. Yes. Yeah. Well, I cannot answer any questions on the astronomical and calculational. Mr. Xenophonimus will tell you about all this. I am a material scientist and a conservator. Any more questions?
Yes. As an additional one along those lines, did Rousopoulos suffer any ill effects from working with potassium cyanide, or were there protections in place?
Oh, potassium cyanide is a poison, but of course he was a chemist and he knew how to protect himself. Yes, nowadays it's not used anymore. It's a poison.
We have a question from Anna Graham, and she asks, are there restorations that were done previously that were damaging to the bronze, and did they have to be fixed? And I'm wondering if she means on the Antikythera mechanism.
The fact that this fragment F is now detached from the lum, from the original lum, it's an achievement of Rousopoulos. I don't think that Rousopoulos did any harm to the mechanism. And I know that fragment F is stuck from many pieces, small pieces. Maybe in the course of detaching it, it broke, but still it has all the information. But as he said, it was a perilous and arduous task. And today, that the mechanism is so famous, we are trembling. we can't touch it. I mean, it's a unique piece. Yes. Every time we have to move it, we feel something. Yes.
Yes. I would be the same. Well, that is summing up all of our questions here. If anyone has, I see one more. Jack Swain asks, do we know what port the Antikythera ship had departed from and or where it was going? From what I've heard, it was possibly headed from Rhodes around Greece and towards Italy, but maybe you know something more or something different.
Yes, this is a question that archaeologists answer. It's not in our field of knowledge, but yes, I have read that it comes from Rhodes and going to Italy. Maybe Pergamon, but I cannot answer this question.
We have another one from Mark Carrao, and he asks, from a conservation perspective, what parts and pieces are allowed to go on tour? So what makes something qualify to be loaned or shared?
There is a list of museum objects that are not movable. One of these are the mechanism. The youth from Antikythera, and some very highly praised and very rare statues and works of art the masterpieces cannot be loaned. But we always offer an alternative piece, work of art.
Mm-hmm. Mm-hmm. Yeah.
This is why the mechanism could not come to Nashville.
Yes, I will say we do have a fascinating replica in terms of having a reproduction. So it looks like the finished product in the wood case, as you said. And we have a touchable hands-on 3D printed version of the artifact, you know, looking like fragment A coming up from underwater. So we have very close seconds. But of course, if you are lucky enough to go to Greece, I highly recommend the National Archaeological Museum because you can see it there, along with many other things that, you know, as Dr. Moraitou said, might be too fragile to travel, and things that, you know, you seeing on site just makes it extra special, I think. So I think that sums up our final questions. So with that, I would just like to extend my thank you to all of you for joining us today for this fascinating symposium. Extend my thanks to Dr. Moraitou for giving us this behind the scenes look at some of the most impressive artifacts in all of Greece, if I dare say the Mediterranean and the world, and sharing about how conservation is important when you find these artifacts. And it's all a step in the process to study and learn more about the past. So I hope you enjoyed it as much as I did. Thanks again to our presenter, to our audience, to our sponsors, Humanities Tennessee, the Centennial Park Conservancy, Metro Nashville Parks and Recreation. And we hope we see you at our next symposium on August 18th. So thank you, everybody. Enjoy your morning or your evening. Bye.
Bye. Thank you very much. Goodbye, Nashville.
Thanks for watching. Be sure to subscribe to our YouTube channel so you're the first to know about all the exciting things happening at the Nashville Parthenon.